Welcome to qnawire.
Okay, we have 3 boxes, and each can contain one isoelectronic group. That is, we are sorting atoms and ions that we've been given into box A, box B, or box C. So we're simply grouping these species into matching isoelectronic series. So we have sodium plus, fluorine minus, helium, lithium plus, potassium plus, titanium 4 plus, sulfur 2 minus, oxygen 2 minus, and beryllium 2 plus. Okay, well, let's consider where all of these things are in the periodic table. Because as it turns out, if we want to find isoelectronic groups, what we're looking for is something like the following example. If we have, say, neutral carbon, right, we know that it has 4 valence electrons in its shell. And if we consider the next atom in the periodic table, or the next element, nitrogen, we know that it contains 5 electrons in its valence shell. If we remove one of those electrons from nitrogen, right, we would have nitrogen plus. So let's do that. Let's say nitrogen neutral goes to nitrogen plus with 4 electrons and a floating electron. Well, as it turns out, now nitrogen with its 4 valence electrons, just like carbon, would be considered isoelectronic with carbon because it contains the same number of valence shell electrons and they neighbor each other on the periodic table. Okay, so that's exactly what we're doing here. So we need to consider which species are near each other, or in a wrapping around sense near each other if they're not quite literally right next to each other on the table, so we can determine if they are indeed isoelectronic. For example, if we start with sodium plus, well, we know that sodium neutral has a single electron and that sodium plus will have removed that electron, right? Which means we will knock down to the previous valence shell, meaning that it would now have 8 electrons surrounding it. And what does this look like? This looks like a noble gas, right? A full octet. And so sodium plus is isoelectronic with the noble gas on the previous row. So let's just take a look. I'm going to mock up a little periodic table here. Hydrogen, lithium, beryllium, a whole bunch of nothing, boron, carbon, nitrogen, oxygen, fluorine, neon, helium above. Right, next row, we've got sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Okay, so if we go from sodium to sodium plus, it's like we're zapping back and or up. So in this case, if we want to go back from sodium, that'll take us all the way back around to neon, the inert gas in the previous row, right? So let's put sodium plus in its own little category here and see if we find anything else that's isoelectronic with it. Well, what about F minus, right? Recall that neutral fluorine has 7 valence shell electrons. If we add 1 to get to fluorine minus, all of a sudden we have a full octet. And since we added an electron, that's moving right on the periodic table. So fluorine minus is isoelectronic with neon and therefore isoelectronic with sodium plus. Okay, helium right here, we know is not isoelectronic with neon, so let's put it in its own category. Sorry, helium. But if we look at lithium, it's exactly the same as sodium was with neon, right? Sodium went back to neon. Lithium, removing electron, will go and become like helium. So lithium plus can hang out with helium. Okay, potassium, right on the periodic table, right down here, potassium plus will behave like argon. So let's put this in its own category. Okay, and now we'll move on to titanium 4 plus. Well, titanium 4 plus is our first transition metal. It's in the same row as potassium. We go potassium, calcium, scandium, titanium. So 4 plus would represent going 1, 2, 3, 4 elements back to argon. So titanium 4 plus belongs with potassium. Okay, what about sulfur 2 minus? We start at sulfur and we move ahead to argon, right? And so argon is what potassium and titanium 2 plus were like. And oxygen, we start at oxygen, we're adding 2 electrons, so we move forward 2, and we end up next to neon. Okay, so let's put oxygen with our other neon atoms. And finally, we have beryllium 2 plus. We start with beryllium and we go 1, 2 back and end up at helium, just like sodium plus and fluorine minus. And now we've sorted our species into matching isoelectronic groups.